In this question, we're given information about the total cost of delivering packages for two companies. There's the flash delivery service and express delivery service. In the case of the flash delivery service, the information is given as an equation. In the case of the express delivery service, the information is given as a graph. What we notice is that both of these representations are linear. But where they're different is that the flash delivery service, the cost is dependent on the number of kilometers driven, whereas for the express delivery service, the cost is dependent on the mass of the package being shipped. Okay, let's go in and fill in the chart now based on what we're given. So we know that this equation is a linear equation, and the number associated with the variable, or the dependent variable here, is the rate of change. And if there was an addition of another number, some value over here, that would represent the initial value. Now, since there is no number shown, that initial value, therefore, would be 0. And if the initial value is 0, we know that this is actually a direct variation relationship. So for the flash delivery service, the initial value is 0, and the rate of change is 3. Now let's look at the express delivery service and the graph. Well, the first point here where it crosses the vertical axis, that would be the initial value. So our initial value here would be 5. And by the way, since it doesn't go through the point 0 down here, we know therefore that this is partial variation. Then to get the rate of change, what we have to do is find the rise over the run, or the slope, of this line. So let's pick a couple of points. We already have this point right there, but let's see where else the graph has another point. We could pick that point there if we want, or we could pick that point there, or that point there. It doesn't really matter. The rate of change would be constant because it is a straight line. So let's figure out then, let's pick these 2 points here and here, and the rate of change is a measure of the rise over the run. So if we look at the rise, if we go from 5 up to 15 here, then our rise is 10. And if we go from 0 over to 4, then the run is 1, 2, 3, 4. And if we divide those two, we would end up with 2.5. So the rate of change for express delivery is 2.5. Now what we have to do is interpret the meaning of the rate of change for the flash delivery service and for the express delivery service. So for flash delivery, this means that the rate of change is $3 per kilometer, because remember, we had the cost dependent on kilometers. And for the express delivery service, the rate of change here means $2.50 per kilogram. Because in this case, remember, the cost is dependent on the mass of the package. Now, if we wanted to be precise and interpret the meaning for both the flash delivery and express delivery services, this equation means that the cost is purely dependent on kilometers. So it's $3 for every kilometer driven. So if you drove 100 kilometers, it would be $300. And if they drove 10 kilometers, then it would be $30. This would be direct variation. Now, for the express delivery service, the cost would be $5 plus $2.50 per kilogram for the package being delivered. So if the package was 100 kilograms, it would be $250 plus 5, or $255. And if the package was 10 kilograms, it would be $25 plus $5 or $30. So this is an example of partial variation.